Hi everybody. Today we're going to talk about equations that have no solutions or infinite solutions. Okay, so here we have three perfectly fine equations and a set of numbers that we can use to solve them. So this isn't the ideal way to solve an equation, but you can just guess and check numbers in. I try and discourage you from doing that. So let's try a half. So we could take 9. Instead of x, I'm going to plug in a half because I think a half might be the solution. Plus 5 equals 4 times a half plus 2 plus 5x. And now I want to see, does a half work? In order to check and see if a half works, I'm going to have to simplify both sides and see if I get the same number. So 9 times a half, multiply numerator times numerator, denominator times denominator, plus 5 equals, I'm going to distribute this 4. 4 times a half is 2. 4 times 2 is 8. Oh, did I leave that 5 as a 5x? No, it's supposed to be 5 times a half, so that would be 5 halves. Let's see, what would I do next? I think I would clear out the fractions. Just multiply every term times 2. All right, so these two cancel and I get a 9. 5 times 2 is 10. I'm going to distribute this 2 to each term inside the parentheses and I get 4 plus 16. And this cancels and I get a 5. So this side is 19. Can you see that this side is definitely not going to be 19? Well, then 1/2 doesn't work. So then we will try 3. Can I clear these drawings out? I bet I can. Erase pen. Boom! Can I write again? Let's try 3. So I have 9 times 3 plus 5 equals 4 times 3 plus 2 plus 5 times 3. So everywhere there was an x, I put in a 3. All right, 9 times 3 is 27 plus 5. On this side, 3 plus 2 is 5. 4 times 5 is 20. And 5 times 3 is 15. Well, this side's going to be 35, and this side is going to be 32. Not the same. So that means that 3 is not a solution. So I could try 6. Erase pen. 6! Instead of x, I'm going to put in a 6 plus 5 equals 4. Instead of x, I'm putting in a 6 plus 2. Instead of 5 times x, it is 5 times 6. So everywhere there was an x, I substituted for a 6. 9 times 6 is 54 plus 5 equals 4. 6 plus 2 is 8. 5 times 6 is 30. We get 59. And 32 plus 30 is not going to be 59, right? So I get 62. Oh, so 6 doesn't work. 0's nice. Checking for 0 is nice. Let me show you how nice that is. So we have 9 times 0 plus 5 equals 4 times 0 plus 2 plus 5 times 0. So everywhere there was an x, I inserted a 0, but zeros are kind of the nuclear option for substituting in numbers. They just destroy terms. So 9 times 0, 0. 4 or 0 plus 2 is 2. 5 times 0 is 0. So I get 5 is equal to 4 times 2. It is not. So 0 is not an option. I could, oh, I'm sorry, that was 0. I could try 0.17 and 11, but they are not going to work. In fact, there is no number that you could plug in that will work. You'll never get both sides of this equal sign to be the same. Isn't that interesting? This equation has no solution. So let's see what happens when we solve this equation algebraically. What does a weirdo equation that has no solution look like when we solve it algebraically? So you guys know that I'm going to simplify first using the distributive property, right, to get all my terms separated. So I have 9 x's on this side and 5 1's. And then 4 times x is 4x, and 4 times 2 is 8 times 5x. So I multiplied 4 times each term inside the parentheses. I can combine some like terms here. So I get 9x plus 5 is equal to 9x plus 8. So far, so good. Everything's working beautifully. I'm going to try and eliminate all the variables on one side by adding a negative 9x, because I know that will eliminate this positive 9x. And I'll do the same on this side. But look what happens. Do you see what's happening right here? I accidentally eliminated the variable on both sides. I wasn't trying to eliminate the variable on both sides, but I did. When I tried to eliminate the variable on one side, I ended up eliminating the variable on both sides. And I get 5 is equal to 8. Now, I hope you can all see that that is not a true statement. 5 is not equal to 8, which means this side of the equation will never be equal to this side of the equation. These two sides can never be equal to each other. This equation has no solution. It cannot be solved. All right. Let's look at the next one. I'm going to go to the next page. Aha. Okay, so now we have 7x minus 10 is equal to 3x plus 14. So now everywhere I see an x, I'm going to substitute in a half. So instead of 7 times x, it's 7 times a half. I'm going to change minus 10 to plus a negative 10. Instead of 3 times x, it's 3 times a half. Everybody with me? 7 times a half is 7 halves, right? Multiply numerator times numerator, denominator times denominator, plus negative 10. 3 times a half is 3 halves, plus 14. I'm going to multiply every term by 2. Every term, not just the fractions, please. Every term by 2. So 2 divided by 2 is 1, and I get 7. Negative 10 times 2 is negative 20. These two cancels, and I get 3. And 14 times 2 is 28. So 7 plus negative 20 is negative 14. 3 plus 28 is 31. They are not equal. So 1/2 is not the solution. Let's try 3. Hope you appreciate me solving these over and over again. I am making a point. So 7 times 3 plus negative 10 equal to 3 times 3 plus 14. So now everywhere, 1/2 didn't work, everywhere I have an x, I've substituted in a 3 just to check and see, does 3 work? So 7 times 3 is 21. 3 times 3 is 9. I'm just simplifying both sides. 21 plus negative 10 is 11. 9 plus 14 is 23. 11 is not equal to 23, so 3 doesn't work. Do you see why it's way better just to solve these algebraically? How painful is this? All right, erase pen. Let's try 6. 1/2 didn't work, 3 didn't work, so I have 7 times 6 plus negative 10 is equal to 3 times 6 plus 14. 7 times 6 is 42. 6 times 3 is 18. 42 plus negative 10 is going to be 32. And 18 plus 14 is 32. There we go. Magic! Both sides are equal to each other. Therefore, the only solution to problem B is x equals 6. When x is equal to 6, both sides are equal to each other. But it's when it's equal to a half, they are not. When x is equal to 3, both sides are not equal to each other. So these are not solutions. You got it? Let's look at C. Oops. I thought I had another screen. That's all right. We'll do C right here. So erase pen. Let's look at C. So for C, we're going to try a half. So I have 3 times a half plus negative 12 is equal to 3 a half plus 1 plus negative 15. All right, so 3 times a half is 3 halves plus negative 12. I have to distribute here. 3 times a half is 3 halves. 3 times 1 is 3 plus negative 15. I think I'm going to get rid of the 2's just to make my life easier. Now that I know how, I'm going to multiply every term, both sides, by 2. And I got a lot of terms, but it's still easier than dealing with the fractions. 2's cancel here, and I get a 3 for that term. 2 times negative 12 is negative 24. 2's cancel here, and I have a 3. 3 times 2 is 6, and 2 times negative 15 is negative 30. 3 plus negative 24, they're going to eliminate, and I get negative 21. 6 plus 3 is 9, plus negative 30. Oh, look at that! It worked! The first number I tried totally worked. That makes me suspicious. Does that make you suspicious? The first number worked. Let's try another one. Let's try 3. What if I did 7? Oops, that's the wrong one. Ah! Oh, that's interesting. That's very interesting. Oh. These are not very professional, are they? All right. We're doing the last problem. So I'm going to try 3 as a solution. Even though we know that 1/2 totally works in here, I just want to check 3 real quick. So I'm going to substitute 3 for x. And I'm going to substitute 3 for x on the other side. 3 times 3 is 9. 3 plus 1, I'm just going to add what's in the parentheses. 3 plus 1 is 4. 9 plus negative 12 is negative 3. 3 times 4 is 12. 12 plus negative 15 is negative 3. What? So 3 works. 1/2 works and 3 works? Let's try 6. Erase pen. Okay, so 1/2 totally worked. 3 totally worked. Trying 6. So 3, instead of times x, we're going to say times 6 plus negative 12 is equal to 3, instead of x, we're going to say 6 plus 1 plus negative 15. Ooh, that was a little off. 3 times 6 is 18. I'm going to do what's in the parentheses. So 6 plus 1 is 7. 18 plus negative 12 is 6. 3 times 7 is 21. Plus negative 15 is 6. 6 also works? Are you kidding me? Would 0 work? We could do 0 really fast, right? Because 3 times 0 would be 0. And this would just be a 1. So I'd have negative 12 is equal to 3 plus negative 15. Oh my goodness. 0 totally works. As it turns out, every single number you try in here is totally gonna work. Isn't that interesting? Let's do a little algebra on this guy and see what we get. So what if we were just solving this the way we usually solve equations without guessing and checking our way to the answer, because that's painful. So we would distribute that 3, right? Because we have the parentheses there. So distribute the 3. And we'd have 3x plus negative 12 is equal to 3x plus 3, right? 3 times x is 3x. 3 times 1 is 3, plus negative 15. I can combine my like terms on this side, and I get 3x plus negative 12 is equal to 3x plus negative 12. I'm trying to get all my variables on one side, so I'm going to eliminate these 3x's by adding 3 negative x's to both sides. So these 3 negative x's eliminate these 3 positive x's. But on this side, they also eliminate. So that's something they have in common. If it has no solution or infinite solutions, when you try and get the variable all on one side, you're going to eliminate the variable on both sides. Variable's gone. Variable's gone always tells you something weird's happening, because remember, our whole job is to isolate the variable. So if the variable disappears on both sides, then it's not a one solution problem. And in this case, I get a statement that is true. Negative 12 is equal to negative 12. And that's how I know I have infinite solutions. Every single real number will work. If you plug in the same number for x on both sides, it will work every single time. Infinite solutions. Plug in any number you want. Isn't that interesting? I think it's interesting. All right, let's solve these. Good practice. So problem number 6. We have 1/3 times 2x plus negative 4 plus 5 is equal to negative 2/3 times x plus 1. All right, I've got fractions here, and I'd like to clear those fractions out. Before I clear the fractions out, I'm going to make sure I circle my terms, because I know when I'm clearing out fractions, I have to multiply times every term both sides, which means I had better know how many terms I have. So I have 3 terms, 2 on this side, 1 on that side. Let's draw a line through the equal sign. Oh, I'm drawing with white. That's not helpful. Okay. So this is all one term, and it has a 3 in the denominator. I could actually rewrite this as 2x plus negative 4 all over 3 if I wanted to, because 1/3 is the same as dividing by 3. I want to get rid of this 1/3. There's a 3 in the denominator, so I'm going to multiply it times 3. And since this is all one term, I'm only going to multiply it once. Here I have a term 5. That's going to have to be multiplied times 3. Here I have a term negative 2/3 times x plus 1, all one term, so I'm only going to multiply it by 3 once. You guys got it? All right, 3 divided by 3 is 1. 3 divided by 3 is 1. So, since this is just a 1 now, the 3's canceled and all that's left is a 1. 1 times 2x plus negative 4 is just 2x plus negative 4. It's one group of 2x plus negative 4, so the parentheses can go away. 5 times 3 is 15. Here the 3's canceled. They left a negative 2 behind, so I'm going to have to keep these parentheses because I have a non-1 factor up front. And then I will distribute, so I get 2x plus negative 4 plus 15 is equal to negative 2x plus negative 2. All right. And then I am going to simplify both sides. I can add this negative 4 and this 15 together, and I get 2x plus 11 is equal to negative 2x plus negative 2. Now I have the same number of x's on both sides, and that's making me slightly nervous that I might eliminate my variable, but I have to try. So to get rid of these 2 positive x's, I'm going to add 2 negative x's to both sides. So these two negative x's eliminate these two positive x's. They're gone. But look at what happens over here. These do not eliminate each other. So I had the same quantity of x's, but they weren't the same sign. And since they weren't the same sign, oh my God, this thing drives me nuts. Thank you. Since they weren't the same sign, they aren't going to eliminate each other. A negative 2x plus a negative 2x is a negative 4x. And then I can add two positive ones to both sides. And two negative ones will eliminate the two positive ones. And I get negative 4x is equal to 13. Divide both sides by negative 4. And I get one solution. There's only one number that will satisfy this equation. An equation is satisfied not when it eats a Snickers. An equation is satisfied when you substitute a number for the variable that makes both sides equal to each other. And for this equation, it would be very satisfied with a negative 13/4. So if you plug negative 13/4 in for the x on both sides, I'll let you do that on your own. Both sides will be equal to the same thing in the end. So they have one solution. All right. So let's look at number 7. Number 7, we have 2 times x plus 1 equals 3x plus negative x plus 2. This is too far over. Hold on, let me start over. All right, let's put it over here. So we have 2 times x plus 1 equals 3x plus negative x plus 2. So to figure out if it has one solution or no solutions or infinite solutions, we will simplify both sides. Simplifying both sides is the key to knowing how many solutions your equation has. So we're going to distribute the 2 because we got parentheses. When we are simplifying, we want to clear out the parentheses using the distributive property. 2 times x is 2x. 2 times 1 is 2. On this side, we have 3x plus negative x plus 2. I didn't circle my terms. I should have circled my terms. Let's do that. So this was all one term, which is why we needed to use the distributive property. On this side, we had 3 separate terms. So now we've got 2 separate terms on the left, 3 separate terms on the right, and I can see that I can add 2 of these terms together. So I can add 3 positive x's to 1 negative x, and I'll get 2 positive x's and 2 positive 1's. Let me pause for a minute right here. Look at this equation. What do we have on the left? 2 x's and 2 1's. What do we have on the right? 2 x's and 2 1's. Both sides of this equation are exactly the same. That is how you're going to spot that you have an infinite number of solutions. So after you simplify, after you fully simplified both sides of the equations, if both sides of the equal sign have the same number of x's and the same number of 1's, there are going to be an infinite number of solutions. And we can keep going. And we could add 2 negative x's to eliminate my variable on this side. But because they were exactly the same, it is going to eliminate my variable on this side as well. And I am going to get 2 is equal to 2. 2 is equal to true. That is a true statement. So this equation has infinite solutions. Any number will work. You can plug in any number you want for x, and it will always work. All right, last problem. Bet you can guess what this one's going to be. So problem number 8, we've got 6x plus negative 5 is equal to 5 times x plus negative 3 plus x. All right. As before, the key to figuring this out is simplifying both sides. So I'm going to check my terms here real quick. And the terms say, we got one simplified term there, 6x, one simplified term here, negative 5. We have an unsimplified term here, a really big term with some math inside. And then we have a term here. So that really big term with the math inside should grab your attention, and you should use the distributive property to break it into two terms, two separate terms. So the 6x doesn't change. The negative 5 doesn't change. 5 times x is 5x. And 5 times negative 3 is negative 15. Everybody still with me? Okay, so now I've got 3 terms on this side. 2 of the terms I can add together. 5x and 6x I can add together. So I get 6x plus negative 5 is equal to 6x plus negative 15. That's a 5. So now that I've simplified it, on this side I have 6 positive x's and 5 negative 1's. And on this side I have 6 positive x's and 15 negative 1's. I have the same number of x's on both sides, but I don't have exactly the same expression on both sides. So now, when I continue solving, I am going to eliminate my variable on both sides. I can't help it. When I try and get rid of the 6 positive x's on this side, I end up getting rid of the 6 positive x's on this side. It's just the way the math works. But then the result is not a true statement. 15 is not equal to negative 5. These are not the same. Not true. And since this statement is not true, and there's no variable, that's the key. There is no variable. It's gone. We know that this will never work. There are no numbers that you could substitute in for x that would give you the same number on both sides. So what we're looking for when we're solving an equation that has no solutions, again, we're going to simplify both sides completely. But once after they're simplified, they are going to have the same x term, so the same number of x's, but a different number of 1's. 5 negative 1's on this side, 15 negative 1's on that side. And then we will know no solutions.